So let's do a quick update on what I've been working on as a little side project. Last time I showed a tool I made to make it easier to generate these objects that you would write into a PuzzleScript game. Instead of having to type them out manually like this, I made a tool that would generate them from an image and then a file that says how to generate like variations of those sprites from that image. Check out the other video to see the details on that. But that is just like one part of a larger idea around making it a little bit easier to develop PuzzleScript games, and I guess to like introduce better practices to doing that, like more general development practices. So what I've done is, so normally if somebody wanted to make a PuzzleScript game, they'd come to the PuzzleScript website, it would bring them to this editor, and they'd write their code in this like in-browser editor, and they'd hit run, they'd debug their game in here, etc. Right? But I was thinking, wouldn't it be nice if I could have my PuzzleScript code in a file on my disk, like I would any other code that I'm writing and compiling and whatever. And then if I could run it from there, that would be great. And then there's some benefits I can get from that, which I guess I'll talk about in a second. So the thing I've done is there's a sample directory I've got over here. This is just on my disk. I'm looking at this in my editor of choice. You could use whatever you like. And then inside the source directory of this sample game, there is a main.ps file. And this is just, it's that same content. It's just the PuzzleScript code. Now, the tricky thing is, how do I actually run this now? And so that's the thing that I've been building, which is, just a bunch of tooling to make it so that I can just run a command and it will build this PuzzleScript game into a website that I can just run in my browser. And so it's a one command thing. If I just go to my terminal down here, so I'm in that sample directory, and I run this command, npx webpack dev server open, you'll see what happens. Opens a new tab. You'll see I've put some like extra HTML around stuff just to test things out. But then the game's running in here and I can do whatever. I can play it as I would have done before. Right? That is a fun puzzle. That like standard first puzzle in that demo. Anyway, so and then the cool thing about this is, so you'll notice I'm running that with the, what was it called? Webpack dev server thing. And that will watch for changes to the files and then automatically reload the game after I've changed it. So if I go to my, let's change like the player color, like the trousers of the player are now going to be dark red. I save and then it automatically reloads. Hit continue, and then my player's trousers are dark red. Yay! Of course, I could also okay, so it's now my game. It's not David Skinner's game anymore. So I'm going to change the author. There we go. That changed. I can also remove that header from the HTML. There we go, and it's gone, and it rebuilt, and everything's great. So why have I done this? So there's a few reasons. First of all, having the source code in a local directory on my machine means I can now version control that like I would any other code. So I can use Git or Subversion or whatever, and make commits, keep track of changes to the code, and it would also help with multiple people collaborating on that same file or whatever. Which is great. Whereas when it's in the editor in the browser, like collaborating is a pain. You would have to copy that code to somebody. In fact, actually, no, you can share the URL. I know the URL has an ID in it, but like, it's just not the way you want to do it. You want to keep track of changes over time and then like be able to merge between different people's work and so on. And then the other thing is that this gives a good basis from which to start doing more interesting things. Like, for example, the thing I showed last time for generating objects from a sprite map, like right now in this, so this doesn't work yet, but right now in this PuzzleScript file, my objects are just written out. But now, because that file's locally and it goes through a build process, I could do some kind of pre-processing where I automatically populate these objects based on that tool that I made before, right? As an example of another thing I could do is I was thinking of maybe integrating something like Ginger. I don't know if you've used that before, but it's like a templating engine. So you could write loops and macros inside your script. So if you've got like a lot of repetitive code, you could write a loop that loops over it and just generates that code instead of having to actually manually type it out. So that's like a couple of the things that it would help with. Yeah, so I guess I could go into a little bit about how it works. The trickiest part was wrapping up PuzzleScript itself, like the source code of PuzzleScript, in a library that I could, or an npm package that I could include in my sample project. So that's what this other directory is up here, the PuzzleScript directory. This is like if you were building a game, you wouldn't ever have to actually care about this. You just install this as a dependency. But what it does is this has within it the actual PuzzleScript source code as a submodule. So it's like pinned to a specific version of PuzzleScript. If PuzzleScript ever gets updated, I just update this package to have the new version of PuzzleScript. And then what it effectively does, let's just look at the index.js. So I'm using some like custom Webpack loaders. How much should I explain? Because maybe it's not obvious what Webpack is. So like the reason I'm using Webpack is because it's basically the de facto standard for bundling things for the web, right? So you have like a complicated application written in multiple JavaScript files, and you want to bundle those up as one thing and then just ship that one file. And it would maybe minify the code in that file or optimize it and so on. So that's what Webpack does. It takes your original source and bundles it up into a single file that you can then just ship with your website. And so I'm attempting to use Webpack as much as possible. I'm using Webpack entirely to do the build processes for both the PuzzleScript wrapping library, the one I'm showing at the moment, and also for building the game as well. It just saves me having to do a lot of stuff like that automatic reloading. When I change the files, that just happens automatically in Webpack because it tracks what the dependencies are between the files. And if you save one, then it automatically reloads for you. Anyway, so I wrote a custom loader for Webpack, which basically just lets me. So this is there's actually not a lot of actual code in here. This is the main file for the PuzzleScript wrapping package. And what it does is it's got a bunch of these lines that say @include in them. And this is the thing that my custom loader does. When it sees these, it basically replaces this line with the contents of that file. And so what it's doing is it's including all of the necessary files from the PuzzleScript source into this one. So this file ends up being this followed by all of the source of PuzzleScript followed by this. And ultimately, what all it's doing in the end is exporting the compile function. And the reason it does that is because, so like the way PuzzleScript is written is it's not built in a very modular or like a. So the way you would write JavaScript for the browser in the past is you would just write a bunch of JavaScript files and you stick them in your browser, and then they'd probably each script would write like global variables, and then the other scripts would just read those global variables the other scripts wrote, and blah 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 blah. Whereas these days, like you typically want to do things in a more modular way and like encapsulate that code and don't expose things as global variables and so on. And so what you do is you write your functions and then you export specifically the functions that you want other people to be able to access. And in this case, all I actually need to be able to access in PuzzleScript is the compile function, because that's the one that you give it the PuzzleScript code, like the game code, and it compiles it and it runs it. Now, I haven't done, there's still a lot of like crazy global stuff going on. This is like the most minimal wrapping I could do of the library of PuzzleScript. I would like to tidy it up even more so it's not doing a lot of that global state stuff, but it's fine for now. So yeah, this means I end up with an npm package that I can use in another Node application just by listing it. So you'll see that in a second, I guess. In fact, I'll just show it now. So that's a package that like wraps up PuzzleScript and exports the compile function. So then in my game, in my package.json, under my dependencies, you'll see PuzzleScript. And currently I'm doing it as a local package. I'm saying, take a look at this directory and use that as the package. Whereas, I mean, ultimately, I'd probably publish this to the npm package repository. So then in my game, all I had to do was write that. And basically, that's it. Well, that's ignoring the there's Webpack config as well. So it's not just that really. But I'm basically, this is saying, I want to use that PuzzleScript package. I basically want to use that compile function from that PuzzleScript package. So then what happens is, let's take a look at the Webpack config for the game itself. So for the game itself, the entry point is the PuzzleScript file, which is in source main.ps. And I'm saying from that, I want to generate a main.js file in my dist directory. But when loading a .ps file, I want it to pass through the PuzzleScript loader. So this is another custom loader for Webpack, which I will later wrap up in its own library. Right now it's in the game directory, but I don't want people to have to write it every time. Although it's very simple. All it does is, so this is the way a Webpack loader works, is it gets given the source, like the content of the file that is being loaded, and its job is to write out some JavaScript that represents that file. So in this case, I'm starting with a PuzzleScript file, and I want to write out some JavaScript that represents that. And so you'll see what it ends up writing out is this code, this JavaScript code, saying, import that PuzzleScript package, the one that I listed in my package.json, i.e. the one that I built that wraps PuzzleScript, take the compile function out of it, and then call compile. I haven't really looked into the details of this, but you pass restart as the first argument, and then the source code itself, like the PuzzleScript game code, as the second argument. And so then what this ends up generating is a file with these two lines and then the source code of the game in that string there, which is what ends up in dist main.js. And you'll see it's actually a bit more complicated than that, and it has a bunch of other stuff around it. That's because Webpack wraps it in a bunch of stuff. But then the cool thing is, at the same time, so in my Webpack config, you'll see that I'm also saying generate a HTML file using this HTML Webpack plugin. I say start with this index.html, which is that file in the source directory, which has a canvas in it and some styles that I've just added. And then what it does, it takes this and it inserts the script, like the script tag that references the main.js script that's been built. So in dist, there's now an index.html, which is not that one. Yes, okay, because when you do it with the dev server, it doesn't actually build it. But if I do npx webpack, this will regenerate this file with all that stuff. There we go. So it's got the style, and then it's got the canvas, and then at the end of the body, it inserts a script tag referencing main.js. And then we just run that in the browser, and it works. And we have the game. Ta-da! So yeah. Next steps, I guess, are to make it so that I can do the ginger stuff in here, so that, so one of the benefits of that would be that I could split out, I already mentioned a few benefits before, like looping and doing macros and things, but I could also split out the PuzzleScript content into multiple files. So if it did get really big, you could maybe have all of your rules in like one file called rules.ps and then include it in this file. So I think that's my next step. Yeah, probably. And then the other thing is, so I built that tool last time for generating objects. Well, it'd be nice to integrate that with this as well. So I could just say something like, I don't know what it'll end up looking like, but if it was ginger, it would be something like this. I don't know. Maybe I have to call a function like generate objects from some file. I don't know. Oh yeah, worth mentioning is I also wrote a syntax highlighting for sublimes just so that the PuzzleScript code would look nice. I don't know if it's particularly complete, but it looks all right with that game. In fact, let me paste my forklift game into it. See how that looks. Hey, not bad. Not bad at all. Cool. Anyway, that's basically it. I can now write my code locally. I can run it from the command line, and it automatically refreshes. That means I can like iterate quickly. It means I can put the code in version control, collaborate on it more easily, and it also means I can build tooling on top of it. And that's everything. Yeah? Yeah. Okay. Bye.